Okay, our next problem is determine current by using superposition theorem for a given network. Okay, that is our problem. So here the current is indicated in this particular branch. Okay, here. So this is our current. So in this 1 ohm resistance, so they are asking about the current, right? So now, so we have two methods. So one is nodal and mesh analysis basis. Second one is by using superposition theorem. Okay. Here the question is asking about superposition theorem. First we will calculate by using nodal analysis. First, in this nodal analysis, first we will identify the number of nodes with respect to ground node. Okay. So here I am considering ground node. This is our ground node 0 volts. And when coming to this one, this is your first node, and this one is your second node, and this one is our third node. Why? Because at this node we have three branches. At this node also we have three branches. Here also we have three branches. Okay, so this is ground. Okay, so here the node voltage is, I am assuming V1. So node 1 having voltage V1, node 2 having voltage V2, and node 3 having voltage V3. Yeah? Okay, three voltages are there. Okay, ground node we have 0 volts. Okay, so by nodal analysis, by node NDA means nodal analysis, right? By nodal analysis at node 1, at node 1. So you can apply KCL for this node, right? You can apply KCL for this node. So what you will get? So here 1 ampere current is entering into this node, so that I am taking minus 1 ampere and plus. So first I will take this branch. So V1 minus V3 by 1, right? If you take this entire branch, so the current in this branch equals to what? Potential difference between these two end nodes by this total impedance. That will use the current through this particular branch, right? So that I am taking V1 minus V3 by 1 ohm. And next, this 1 ohm branch is connected to this first node. So that V1 minus V2 by 1 ohm. Current through this particular branch equals to how much? The potential difference between these two end nodes by this 1 ohm resistance. So that I will get V1 minus V2 by 1 ohm. Already I told you, whichever the node you can consider, whichever the node you have to consider, that node voltage is superior than all other nodes present in the network. Okay, first I am considering node 1 voltage, so that this node 1 voltage is superior. That means higher value while comparing all other nodes present, all other node voltages present in this network, right? So even the same thing apply for all the nodes. Okay, if you take node 2 is the reference, so this node 2 voltage is superior than all other node voltages present in the network. In the same way, node 3 also. If you apply the KCL, if you apply the KCL at this node 3, so this node 3 voltage is superior than all other node voltages present in the network. Okay, so already these things I explained in nodal and mesh analysis, right? So now, so this branch is current over, this branch current also over, and this branch is left, right? So here the end voltage difference equals to how much? V1 minus 0 by 1 ohm. So that I am taking V1 minus 0 by 1 ohm, which is equals to 0. This is node equation 1. Okay, similarly you can write the nodal expression for node 2. At node 2, that means this is the reference one. Okay, so this node 2 voltage is superior than all other nodes present in the network. So now you can apply KCL for this node. Okay, so here we are connecting three branches. One is 1 volt branch, another one is 1 ohm branch, another one is 1 ohm branch. If you apply, so from this entire branch, here we have 1 volt. Okay, here we have 1 volt, and here we have the node voltage equals to how much? V2. So that V2 equals to 1 volt or not. So in between, we don't have any other components, right? So whatever the 1 volt is there, so that 1 volt is up here at this node end, right? so that we are directly connecting V2, that means V2 equals to 1 volt. Okay, V2 equals to 1 volt. Okay, and if you write the expression for this node, so V2 minus V1 by 1 ohm plus this V2 minus V1 by 1 ohm and V2 minus V3 by 1 ohm, V2 minus V3 by 1 ohm, which is equals to 0, right? Don't take this one, right? So this V2 equals how much? 1 volt. That 1 volt you can substitute here. Okay, that 1 volt you can substitute here. Okay, so this is expression 2, and similarly you can apply the nodal expression for node 3. At node 3, so first this is your node 3. So we have 3 branches, this 1 ohm and this 1 ohm and this 1 ohm. Okay, now you can apply the KCL. So by KCL, first one I will consider this branch. Okay, so in this branch the current equals how much? V3 minus V2 by 1 ohm. Okay. V3 minus V2 by 1 ohm plus, and if you take this branch, okay, V3 minus V1 by 1 ohm. Okay, V3 minus V1 by 1 ohm plus, and this branch, so V3 minus 0 volts by 1 ohm. So V3 minus 0 volts by 1 ohm, and which is equals to 0, and this is your third equation, right? So now, so by solving these 1 2 3 equations, okay, by solving 1 2 3 equations, you will get V1 equals to V2 equals to V3 equals to, right? So these value, but you have you have V2 equals how much? 1 volt. So you can substitute here 1 volt. And if you substitute this V2 value in all three expressions, you will get V1 as well as V3. So here the V1 equals to 7 by 8 volts and V3 equals to 5 by 8, 5 by 8 volts. Once you simplify, so you can evaluate these values. Okay, just I got 7 by 8 and 1 volt and 5 by 8 volt. Okay, so this is the way you have to evaluate the voltage values. Once you will get this, so what is the current we require? So current in this branch, right? So in this branch current, that current expression I equals to, so the direction of current is towards this, right? That means V1 to V3 is current flowing, right? So in that case, we are getting V1 minus V3 by 1 ohm. But here I equals to V1 how much? 7 by 8, right? And V3 how much? 5 by 8, okay? By 1 ohm, okay? 7 by 8 minus 5 by 8, that is 2 by 8 volts by 1 ohm, volt by ohm. So you will get 1 by 4 amperes, that equals to 0.25 amperes. This is the current you are getting from V1 to V3 voltage. Otherwise, first node to third node, the current is flowing 0.25 amperes. So this is the problem, right? So if so, this much of time will take to evaluate this I value with that means by using this nodal analysis, right? So if you are using superposition theorem, so here we have only two sources, right? We have two sources at a time. You can consider one source and you can evaluate the current value. Okay, first you can take a 1 ampere current source and you can ignore the 1 volt by shorting this path. Then you can find out the current, that is indicate with I1. And next you can consider 1 volt voltage source. You can ignore the current source by opening the circuit, and then you can evaluate the I2 current. Now you can add those two currents, I1 and I2, then you will get I current that equals 0.25 ampere. Okay, we will go by superposition theorem also. I will take okay, wait a second. Right. First, I'm considering this 1 volt voltage source. Okay, case 1. With respect to 1 volt voltage source. 1 volt voltage source. Okay, just I'm considering the source. I'm ignoring this 1 ampere source. Okay, that means 1 ampere current source considered as open circuit, right? 1 ampere current source should be considered as open circuit. Okay, now I will redraw the circuit. Then just I'm getting circuit like this. Sorry. Okay, so this should be considered as open circuit. Okay, and I'm considering this 1 volt voltage source only, and all the resistors having 1 ohm resistors, and here I'm considering the current value I1. I'm indicating with I1, right? Okay, now, so this is completely open circuit. You ignore this path. Okay, right? So now, just you can for this circuit, you can indicate the node symbols. Okay, so here I'm considering a. This is a node. Okay, this should be considered as a. Okay, and wait a second. This should be considered as A, and this should be considered as B, right? And the next one, this should be considered as a C, and this should be considered as node D. Okay, now you can pull out this AB terminal. Okay, just you can pull out this AB terminal. That means the source, you can bring out the source. Okay, so while I'm taking this AB source, okay, just I'm getting circuit like this, minus. Okay, and I'm taking the terminals, this one A, and this one B, and this one C, and this one is D, right? Just I will form a one bridge. Okay, now you can take the terminals, terminal nodes, and in between the terminal nodes, whatever the element is there, that element you can draw here. Okay, then you will get so for example, if I'm taking A and B, so in between A and B, we have source, right? If you take this A and B terminals, so we have a source that is 1 volt voltage source. I'm taking 1 volt voltage source in between A and B. Now I'm taking C and D. So if I'm taking C and D, so in these two nodes, we have 1 ohm resistor with the amount of current flowing through that 1 ohm resistor is I1, that you can indicate in between C and D. So here we have a 1 ohm resistor, okay, and here the current equals to how much? I1. Clear now? And now you can indicate the rest of the elements in between the nodes. I'm taking A and C, so this is A and this is C. In between A and C, we have 1 ohm resistor, so that I'm taking 1 ohm resistor. And next A and D, so this is A and this is D, 1 ohm resistor, and next C and B, so this is C and this is B, so we are getting 1 ohm in between C and B. And next B and D resistors, in between these two terminals we have 1 ohm resistor, so that I am taking here 1 ohm. Clear? So this is the circuit. This is one bridge circuit by connecting 1 volt voltage source, right? So, all the terminals are mentioned here, and all the elements also mentioned here. So, and that means what? Same circuit, I can rearrange the circuit like this. Okay, like as bridge circuits. If you observe this cross So whenever you form the bridge network, while checking whether it is balanced bridge or not, in that case you can take opposite resistance product. Okay, if you are considering opposite resistors, just you can take product. Okay, that means 1 into 1 ohm equals to this 1 ohm into this one. Okay, so that means if you are considering opposite resistors, you can take the product. If you are considering same side resistances, then you can take the division. That means 1 by 1 ohm by 1 ohm, which is equals to, and if you consider this side, that is 1 ohm by 1 ohm, so you will get 1 equals to 1. If you take same side, you will take division. If you take opposite resistances, you can take the product. If those two products are equal, otherwise if those two divisions are equal, then it satisfies the balanced bridge condition. Okay, that means which satisfies the balanced bridge condition. Okay, balanced bridge condition. Okay, so if the circuit, if the bridge is balanced, the current flow through this particular resistor equals to how much? 0. That means I1 equals to how much? 0, right? In the case 1, so if we are evaluating this I1 value, that I1 equals to how much? 0 amperes, right? This one is over. Okay, and next, just you can pull this 1 ohm, sorry, this, just you can pull this 1 volt voltage source, and you can replace, just you can take the 1 ohm resistor in between these C and D terminals. Okay, same thing I can rearrange in this circuit, right? Okay, so this is over. This is case 1. Just you can consider case 2. Just I am taking case 2 here, otherwise I will go to next page better. Okay, next case 2. Okay. So in this case too, I am considering 1 ampere current source with respect to 1 ampere current source. Okay, with respect to 1 ampere current source. Okay, that means what? By ignoring this 1 volt voltage source, that means 1 volt voltage source should be short circuited. Okay, 1 volt voltage source should be short circuited. Okay, now I redraw the circuit. So this is 1 ampere current source, and this is 1 ohm, and this is also 1 ohm, and this will act as a short circuit. Okay, again this one having. Okay, so here also we have 1 ohm resistor, right? So 1 ohm, 1 ohm, 1 ohm, 1 ohm, 1 ohm. But here we need to evaluate I2 amount of current through this particular 1 ohm resistance. Okay, okay. Now if you observe this particular point, okay, so from this point to this point, this is complete one single path, right? This one single path without any element, this is complete short circuit, right? So this, if you observe this node and this node, both are same or not? Why? Because in between these two nodes we don't have any other components. That means we don't have any voltage drop, right? This entire path having 0 volts voltage drop, right? So that, so this node and this node are same. Okay, you can split, that means you can that means these two are acting as one single node. That I will redraw the circuit like this, so which is equivalent to, this is 1 ampere, so this is 1 ohm resistor, and this is also 1 ohm resistor, and this point also same. I'm not disturbing this one also. So this is 1 ohm, 1 ohm, 1 ohm, right? So here we need to evaluate this I2 amount of current. Now if you observe these particular configuration, only this particular configuration you can focus, right? So first I will consider this entire thing as one particular node. In that case, what happened? So here I'm getting a resistor like this, okay, and similarly getting one more resistor like this, okay. That means this path, okay, this 1 ohm resistor having two terminals, right? One terminal is connected at this point, and the second terminal should be connected to at this point, right? This is entire one path, right? At this point the second node is connected, that means second terminal is connected, right? So that's why I'm taking a path like this, right? And in the same way, if you observe this particular 1 ohm resistor, this one end is connected at this point, clear, and the second is connected to at this point, and this is connected to this point. That means this entire path should be connected to at this point or not. Just I am considering only one particular point, okay, don't take these 2 points. That means this point merges at this point, right? So that I am getting path like this, okay. So now if you observe, these two are in parallel, right? These two 1 ohms are in parallel, and these two 1 ohms are in parallel, right? Two same resistors are in parallel, which results the equivalent resistance how much? Half of the this particular same resistance, right? That means 0.5 ohm. Here also we are getting 0.5 ohm. Now the resultant circuit is, this is 1 ampere, and here the resultant resistance equals to 0.5 ohm, and here we have the resultant resistance of 0.5 ohm, and this one is connected to 1 ohm resistor, and here the current equals to I2. And if you observe, so this is 1 ohm and this is 0.5 ohm, okay, both are connected in what? Series connection. That means we are getting 1.5 total, right? So here I'm considering this is 1 ampere, 0.5 ohm, and here I'm considering 1.5 ohm, and here the current equals to how much? I2. So this is like a parallel circuit, okay, all three are connected in parallel, but here the source is current source, okay, which the source can be delivered 1 ampere current for this entire network, right? So now in order to evaluate I2 current in the second element, this you can apply current division principle, okay. By current division principle, already you know the current division principle. సో మీరు ఏ ఎలిమెంట్లో అయితే కరెంట్ ఫైండ్ అవుట్ చేయాలనుకుంటున్నారో ఆ ఎలిమెంట్ రెసిస్టెన్స్ కాకుండా రిమైనింగ్ ఎలిమెంట్ రెసిస్టెన్స్ ఇంటూ సోర్స్ కరెంట్ ప్రోడక్ట్ బై టోటల్ ఇంపెడెన్స్ తీసుకోవాలి, ఓకే. దట్ మీన్స్ వాట్? హియర్ I2 ఈక్వల్స్ టు, ఈ ఎలిమెంట్లో ఫైండ్ అవుట్ చేయాలి కరెంట్, కాబట్టి ఏం చేస్తారు? ఈ ఎలిమెంట్ రెసిస్టెన్స్ తీసుకుంటారు 0.5 ఇంటూ సోర్స్ కరెంట్ ఏదైతే అమౌంట్ డెలివర్ చేసిందో ఆ అమౌంట్. ఇక్కడ వోల్టేజ్ సోర్స్ ఉన్నా పర్లేదు, ఓకే, బట్ ఇక్కడ వచ్చే కరెంట్ కావాలి మీకు, అంటే ఫైనల్గా సోర్స్ నుంచి వచ్చే కరెంట్ మీకు కావాలి, ఓకే. దట్ కరెంట్ 1 ఆంపియర్ బై టోటల్ ఇంపిడెన్స్. ఇక్కడ 0.5 ఉంది, ఇక్కడ 1.5 ఉంది. సో 0.5 ప్లస్ 1.5 ఓమ్, ఓకే. సో హౌ మచ్? సో దిస్ ఈస్ 0.5 and this is 2. So 0.5 by 2 means what? 0.25 amperes, right? So already previously we have so here linear sum of the current. Superposition theorem is nothing but what? A linear sum of the current. So the total current I equals to what? I1 plus I2, okay. But I1 equals to how much? 0 amperes. Already we evaluated this one. So here I am getting I1 equals to 0 ampere, right? And here I am evaluating I2, that is 0.25 ampere. So here we can substitute a 0.25 ampere. Then I equals to how much? 0.25 ampere, right? This is the current. This is by using superposition theorem. So whatever the method you can prefer, you will get same answer. Here I am using nodal analysis approach. By nodal analysis I am getting 0.25, and for the same circuit you can apply mesh analysis also. While applying mesh analysis also you will get same amount of current, okay. and by applying superposition theorem also you are getting same amount of current. But this one is somewhat a easy method while comparing to that nodal analysis. Okay, here I am writing all these connections. Okay, ఇక్కడ మీకు అన్ని నేను డ్రా చేశాను, బట్ మీకు ప్రాక్టీస్ చేసిన తర్వాత మీరు ఈ కనెక్షన్స్ అన్ని డ్రా చేయరు, చూడగానే ఆన్సర్ పెట్టేసే విధంగా ఉంటుంది. ఓకే, మీరు ఇక్కడ నోడ్ కనెక్షన్ తీసేసి నేను ఈ నోడ్ కనెక్షన్ మీకు అర్థం అవడం కోసం మీకు ఇలా డ్రా చేశాను, బట్ మీరు ప్రాక్టీస్ చేసిన తర్వాత మీరు ఇలా డ్రా చేయరు. సో దిస్ 1 ohm parallel, this 1 ohm parallel, and this parallel 0.5, and this is 1.5. So by current division principle, I2 through this 1.5. So here 0.5. Okay, this 0.5 into 1 ampere by 0.5 plus 1.5. Direct step is ఇదంతా క్యాలిక్యులేషన్స్ అంతా ఉండవు, అది ప్రాక్టీస్తోనే వస్తుంది. ఓకే, సో సోర్సెస్ రిమూవ్ చేసి క్యాలిక్యులేట్ చేయడం అనేది ఈజీ అన్నట్టు, తొందరగా మీకు అంటే తక్కువ టైంలో ఆన్సర్ అనేది మీకు గెటిన్ అవుతుంది. ఓకే, బట్ మనకి డిస్క్రిప్టివ్ ఎగ్జామ్లో ఎలా ఉంటుందంటే డిటర్మైన్ ఐ బై యూజింగ్ సూపర్పోజిషన్ థియరమ్ అంటే డెఫినెట్గా సూపర్పోజిషన్ థియరమే ఫాలో అవ్వాలి. బై యూజింగ్ నోడల్ అనాలిసిస్ అంటే నోడల్ అనాలిసిస్ మాత్రమే ఫాలో అవ్వాలి. ఓకే, నేను ఏది అడిగినా మీకు వచ్చిందే చేస్తాను అంటే అక్కడ మార్క్స్ అనేది ఇవ్వరు. ఓకే, మీకు నోడల్ మాత్రమే తెలుసు, సూపర్పోజిషన్ తెలియదు. నేను క్వశ్చన్లో బై యూజింగ్ సూపర్పోజిషన్ థియరమ్ అని అడిగాను, బట్ మీరు రాయడం మాత్రం నోడల్ అనాలిసిస్లో చేశారు. అప్పుడు నేను ఎట్టి పరిస్థితుల్లో మార్క్స్ అనేది ఇవ్వను, కంప్లీట్గా 0 మార్క్స్ అనేది ఇస్తాను. ఓకే, సో క్వశ్చన్ ఏం అడుగుతున్నాడు అనేది ఇంపార్టెంట్, ఏ టెక్నిక్ యూజ్ చేసి సాల్వ్ చేయమంటున్నాడు అనేది చాలా ఇంపార్టెంట్. క్వశ్చన్ ప్రాపర్గా చదివిన తర్వాత ఆన్సర్ అనేది ట్రై చేయండి. ఓకే, ఓకే, దిస్ ఈజ్ అబౌట్ superposition theorem related problem.